But why do we need to care about separating responsibilities? That's because a class with multiple responsibilities leads to rigid and fragile design. These are the enemies of maintainable software. In order to understand rigid and fragile design, I need to know who is using my class. Consider our employee class again. Let's say we have two applications using the employee class. One is called HR Personal, which needs to access the employee details so that it is able to display them in a report. The other is called Finance Calculations, which uses the employee class to get the bonus amount so that it is able to compute the final salary. Now recall the requirement to change the bonus calculation method. For this, we need to change employee class. We also need to at least test finance calculations to see that it is not broken. For languages such as C++, depending on the type of change, it might even involve recompiling and redeploying finance calculations. But this is not enough. We would also need to repeat the same exercise for HR Personal. If we do not do it, there is a chance that HR Personal may break in unpredictable manner. Surprised as to how this could happen? Let's go through a hypothetical example to understand it. Assume that the employee class has a private method called trimID. This method is used by getEmployeeID as well as calculate bonus methods. Let's look at why they need to use this private method. Suppose employee ID is a 10-digit number, but nobody cares about the first 6 digits. The function of the trimID method is to trim the first 6 digits and return the last 4. The getEmployeeID simply uses the trimID method to return the last 4 digits of the employee ID. HR Personal uses this 4-digit employee ID along with other details to display them in its report. That was about why getEmployeeID needs to use trimID function. Now coming to why calculate bonus method also uses the trimID method, consider this. The calculate bonus method uses an algorithm to calculate the bonus of an employee. The algorithm takes various factors of the employee into consideration, one of these being the employee ID. Now the algorithm also needs only the last 4 digits of the employee ID. Therefore, it also uses the trimID method. To summarize, the employee class has a private method called trimID, which is used by two public methods, getEmployeeID and calculateBonus. Now let us bring our new requirement where we said that the bonus calculation method needs to undergo a change. The new requirement says that the bonus calculation algorithm has to now use the last 8 digits of the employee ID instead of the current 4 digits. So, the developer responsible for this requirement modifies trimID method to return the last 8 digits. He then tests finance calculations and submits his changes. Result: HR Personal crashes because it had allocated just enough space to accommodate a 4-digit employee ID for its tabular report. A not so ideal example, but just enough to show the consequence of violating single responsibility principle. A rigid design is one in which it is difficult to change the software, A single change causes changes in multiple places. Our design was rigid to some extent because a single change in employee bonus calculation had an impact on multiple places, including HR personnel, an example of a rigid design. A fragile design is one in which a change in one functionality breaks some other functionality. Often it happens that the broken functionality is not even related to the functionality that was modified. Our design was also fragile because if we had failed to adapt and rebuild HR personnel, the application could have broken. Just imagine the change was made for bonus calculation, but the application that breaks is the one that shows employee report, an example of a fragile design.